Perovskite solar cells convert light into electricity more efficiently than earlier kinds of solar cells, and manufacturing advances have recently made them commercially attractive. One limitation of the cells, however, has to do with their electron transport layer, ETL, through which absorbed electrons must pass. Often, the ETL is applied through a process called spin coating, but such ETLs are fairly inefficient at converting input power to output power. André Taylor and colleagues tested a novel spray coating method for applying the ETL. The team produced ETLs of various thicknesses and concluded that spray coating holds promise for improving the power conversion efficiency of ETLs in perovskite solar cells. Which choice best describes data from the graph that support Taylor and colleagues' conclusion? A. Both the ETL applied through spin coating and the ETL applied through spray coating showed a power conversion efficiency greater than 10% at their lowest performing thickness. B. The lowest performing ETL applied through spray coating had a higher power conversion efficiency than the highest performing ETL applied through spin coating. C. The highest performing ETL applied through spray coating showed a power conversion efficiency of approximately 13%, while the highest performing ETL applied through spin coating showed a power conversion efficiency of approximately 11%. D. There was a substantial difference in power conversion efficiency between the lowest and highest performing ETLs applied through spray coating.
Question number 13, we have the graph given. This graph title is Power Conversion Efficiency of Lowest and Highest Performing Spin Coated and Spray Coated Electron Transport Layers. So spray coating is indicated by the grey bars, whereas spin coating is indicated by the black. And they have shown for both lowest performing and highest performing. So what we have to do here, first of all, they are talking about perovskite solar cells. So what do? They convert light into electricity more efficiently than the earlier kinds of solar cells, and manufacturing advances have recently made them commercially attractive. So these are very good and they are more efficient to convert solar light to electricity. But there is a limitation. One limitation of the cells, however, has to do with their electron transport layer, which we call it as ETL, through which absorbed electrons must pass. But often the ETL is applied through a process called spin coating. So earlier they were doing spin coating, but such ETLs are fairly inefficient at converting input power to output power. So then André Taylor and colleagues tested a novel spray coating method, but now instead of this spin coating, they are trying a spray coating method to apply the same thing, ETL, which is the electron transport layer. And the team produced ETLs of various thicknesses, and what did they conclude? They concluded that spray coating holds promise. It's showing some promise. That means it's showing better efficiency compared to the spin coating, the spray coating which they have found. This improves the power conversion efficiency of ETLs in perovskite solar cells. And what do we have to do? We have to choose that choice which best describes data from the graph that support Taylor and colleagues' conclusion. We have to support Taylor and colleagues' conclusion and show that the spray painting is more efficient compared to the spin painting for this ETL. So which answer we should choose? So if we observe A, it says both the ETL applied through spin coating and ETL applied through spray coating showed a power conversion efficiency greater than 10% at their lowest performing thickness. So lowest performing thickness, yes, even the spray coating is more than 10%, it's almost 15%, almost very close to 16%, and spin is also more than 10% over here. But this will not show anything related to spray coating being more efficient. So we cannot choose A. But if you said B, well done, that is the best answer. So over here you can see that the lowest performing ETL applied through spray coating. So why we have to choose this? Because even the lowest performing ETL applied through spray coating. So even though this is a low performing ETL, even then this lowest performing ETL applied through spray, this is the spray, it has a higher power conversion. This is almost 15%. And at the same time, highest performing also by spin coating, it is able to reach only more than 12, let's say 13%. So lowest performing by spray painting is higher than highest performing by spin painting. So this will clearly prove that Taylor, what he's saying, that this is a promising thing to use. So if we choose B, it will support Taylor's conclusion about spray coating compared to spin coating, because spray coating, even in lowest performing, it is able to give a very greater efficiency, whereas even in highest performing, spin is giving very low efficiency. That's why B is the best answer.
Choice A is incorrect. Although this claim correctly describes the data in the graph by stating that both the lowest performing ETL applied through spin coating and the lowest performing ETL applied through spray coating had a power conversion efficiency greater than 10%, this relationship in the data doesn't support or relate to Taylor and colleagues' conclusion that spray coating promises greater efficiency for solar cells than traditional spin coating does. Choice C is incorrect. This claim does address the greater power conversion efficiency of the highest performing ETL applied through spray coating compared with the highest performing ETL applied through spin coating. However, it also incorrectly cites the value for the efficiency of the highest performing ETL applied through spray coating as approximately 13%, instead of a value between 14 and 16%, and the value for the efficiency of the highest performing ETL applied through spin coating as approximately 11%, instead of a value between 12 and 14%, as shown in the graph. Choice D is incorrect because Taylor and colleagues' conclusion is based on the difference in the power conversion efficiency of ETLs applied through spray coating and that of ETLs applied through spin coating, not on the difference between the highest and lowest performing ETLs applied through just spray coating.